Hello, hello. This song is called Lovely Peace by Day Fox. Grab your drinks. We're getting started in about a minute. Get your packet ready. Hello, hello. Hello. All right. So, let's get started, I guess. No? So, how are you guys? Having fun? Nice Monday, lovely morning. I mean afternoon, I guess. Not morning anymore. Oh, this is the first class. I feel like it should be morning. It's first period, right? Alright. So today we're gonna talk about, remember all those general sequence that makes it hard for you to get patterns, or not hard, but like unpredictable sometimes. So we're gonna talk about them a little bit. So before this, let's look at these two figures right here. Figure 1 and figure 2, right? Can you see that? So these are called triangular numbers. Why? Because they look like triangles. If you look, figure 1 is a picture of 1 plus 2 plus 3, right? Which is 6, right? 1, 2, 3, 4, 5, 6. But it's 1 plus 2 plus 3, right? Figure 2 is 2 times that, right? Because you have 1 here and 1 there. Agree? Okay. So, can you draw a similar picture of 2 times 1 times plus 2? So, for example, 1 plus 2 is like 1, right? 2, 1 plus 2, right? But you have 2 times them. So, I'm going to do like 2 different colors. Kind of like this. Okay. Okay. And then we're going to do one with 1 plus 2 plus 3 plus 4. Which means 2, 3, 4, right? And then you're going to do it with the other side as well, right? 1, 2, 3, 4. 1, 2, 3. 1, 2, and 1. So 1 plus 2 plus 3 plus 4 on both ends, okay? And can you finish up with the right side, this one? You want to mark them as different, okay? All right, so once you're done, let's look at number 2. So number 2 is the number of dots, both black and white. I guess in our case is red and blue. In figure 2, which is this one. Oh, black and white, yeah. So it's 3 times 4, right? If you look at it, it's 3 times 4. But we can also view this as 3 times 3 plus 1, right? It says we can view it as 3 times 3 plus 1. Why? Well, because not only is this a rectangle, right? It's also 2 triangles, right? If you can see, this is 3, right? And then times 4, but this 4 is really just 3 plus 1, okay? Why is this helpful to think 4 as 3 plus 1? What do you think that is? Well, to be more methodical, you can say we have 3 from black, right? And then 3 white plus 1 black, right? This is your width, right? This is your length, right? Does that make sense? This one, 3 times 4, right? They say incomplete sentence. I know you're better at that than me, so I'll leave it to you. Write in understandable language. Alright. So, if you look at this then, figure 2. Since the whole thing is 3 times 3 plus 1, if we just want half of that, which is just 1 triangle, because this is a rectangle, right? This is 2 triangles together. If we just want 1, wouldn't it make sense to just divide by 2? Like this. Okay. So 3 times 3 plus 1 over 2. Sounds kind of familiar. Well, let's write similar equations for part A, part B, part C. Part A, we had this one, right? This one. So this is 2 times 1 plus 2, right? For A. B was 2 times 1 plus 2 plus 3 plus 4, right? C was 2 times 1 plus 2 plus 3 plus 4 plus 5, right? So I'm going to show you something. So because of this, right? We can also see this as 2 times 3. We can also see that one as 4 times 5, right? 4 times 5. And we can also see that one as, I think, end up being 5 times 6. But regardless, you can rewrite this as 2 plus 1, right? And then 4 plus 1, 5 plus 1, right? Like that. Okay? Now, if you only want one part of triangle, because this is 2, right? This is 2. 2 of them. If you just want one, wouldn't you divide it by 2? This is 2, right? 2, 2, 2. If you only want one, wouldn't you divide by 2? This is called one triangle, right? So, what do they all have in common? Don't they have, what? 2, 2 plus 1, 4, 4 plus 1, 5, 5 plus 1. What is changing? This 2 is changing, right? 4 is changing, 5 is changing. So that number is changing. How is it changing? It's n plus 1 over 2. Okay? So how could you use these dots to convince someone the answer in A? So, which means, what is 1 add 2 add 3 all the way to 100? What is that? How can we use dots to convince someone that is true? Have an idea? All right, so let's take a look at this. So this is equivalent of, so 1 plus 2 plus 2 plus 3 all the way to 100, right? If you look at dots, that means you need to have 1, 2, 3, all the way to what? 100, right? All the way to 100. And then the other side, you have the same thing, right? This part will be 100. And this part, right, will be 100. Same thing. So you'll form a triangle here and triangle here. But the actual width of this would be 100 plus 1, right? 100 times, I'll use this, 100 plus 1, right? Over 2. Because you only want one triangle there. 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to 100. But I count the whole thing so that I can divide by 2. Because the whole thing is a rectangle. Okay? So that ended up being 50-50. Okay. All right. So let's do the survey again. Comfort level 1 to 10. Give me a number. 1 to 10. Is everyone still online? You guys still here? It says I have 31 concurrent viewers, but nobody's responding, so I don't know if you guys are actually there. Got a 7, 6. Yes, we are here. Give me a number. 8.32. 4. Okay. It's normal that you kind of don't get it. So, like, let me give you a kind of like a different explanation. Let's look at this. So let's say we want to add 1 plus 2 plus 3 plus all the way to 100, okay? Let's add it in a different way. Let's flip it, okay? 100 plus 99 plus 98 plus all the way to, what, this is 99, right? So this is, what, 2, and the last one's 1. What do you notice about these? All these. What do you notice? How are they related? Give me something. They add to 101, right? So add together, you can go get 101 plus 101 plus 101 plus all the way 101 plus 101, right? How many 101s are there? How many 101s? How many 101s? 100. So the total of this should be 100 101s, right? But the initial question, I only asked for one side, right? Not both. So I divide by 2. See that? See your 100 times 100 plus 1 over 2? See this part? Okay. So this is in number terms, okay, without the triangle. Or this is a triangle but with numbers. Is this making more sense? So in other words, if you're in this kind of motion triangle, you add the first and last times number of terms, divide by 2. What does it sound like? What does it sound like? Okay. Remember there's a thing that you also add two things together times something divided by 2? Remember there's a thing in geometry called the trapezoid? Right? Remember trapezoid? Trapezoidal formula for area, isn't it what? Base 1 plus base 2 times height divided by 2? Do you find some similarities in here? Right? First term, which is 1, right? First term, 1, plus last term, which is 100. You can treat the first term as 1, last term as 100, right? Because that it goes down in a constant manner, right? Because you are increasing 1. Right? Times height, which is how many terms you have. In this case, is 100 terms. Divided by 2. That will give you the whole area, the whole sum, basically. Okay? We're going to talk about how geometry relates to algebra sometimes. Right? Does that part kind of make sense? You can think about it as all these dots are lining up in the ordered way. Right? Okay, now, that being said, let's look at this part. What is 1 add all the way to n then? Well, we kind of already solved that. It would be n plus 1 over 2, right? That would be the sum. How could you use the dots to convince someone that your answer in A is correct? Well, it's the same, all right? It's triangular. Okay, you can say triangular with side n, or n dots in this case. Okay? All right. All right, so let's look at this. 6 equals 1 plus 2 plus 3. 10 equals 1 plus 2 plus 3 plus 4. And so on and so forth, right? So let's look at this, okay? So we're going to circle consecutive triangular numbers. What does that mean? Look at this. This is 1, right? This is 3. So the next one will be 3 and 6. Right, and then the next one will be what, 6 and 10? What would be the next one? It would be 10 and what, 1 1 plus 2 plus 3 plus 4 plus 5, that's 15, right? And then next one would be 15 and 21. Doesn't this sound familiar? Doesn't it sound familiar? Right? Doesn't it sound familiar? Didn't we do this in the general sequence before? It was like 1, 3, 6, 10, 15, 21. So before you continue, let's look at this. Okay, so T1 is 1. T2 is 1 plus 2, which is 3. And T3 is 6, right? So this is 1 plus 3, right? 2 squared is 1 plus 3. 3 squared, why don't it's 1 plus 3? Because 2 squared is a square, right? 2 times 2. 3 squared is this, which is 3 plus 6, which is T2 plus T3. Obviously, T4, T3 plus T4 will be 4 squared. And then T4 plus T4 plus T5, and then T. Whoa, okay, wait, no. Come back. This is not, because they skipped one. Okay. So knowing this pattern, you see how this works. T2 squared is T1 plus T2. 3 squared is T2 plus T3. 4 squared is T3 plus T4. And 6 squared should be what? T5 plus T6, right? I'm going one backwards, basically. T15 will be 14. 15 squared will be 14 plus 15. This is talking about term number, okay? I'm not talking about the actual number. It's the 15th triangular number plus the 14th triangular number. So in this case, this will be Tn minus 1 and Tn. Okay, these are the which triangular number you're talking about. Okay. All right. Let's look at this real quick. Take some time to digest. It's a little difficult. All right, comfort level before we move to the last problem of the day. 1 to 10. We're talking about triangular numbers. Basically, these are numbers of the sum from 1 to wherever. That's called triangular numbers. Okay, they look like triangle. That's why it's called triangle numbers. Comfort level. Give me something. 1 to 10. No comfort level, not comfortable at all. Got a 7. Got an 8. Okay, that's not bad. I mean, 2 people responded, but okay, 8, very good. Keep typing. I'll give you some time to show your comfort level. 8, good. 7, good. 7. Hey, not bad, you know? Not bad. Okay. Good. Alright. So, let us look at this. You read it first, and I'll take attendance, okay? If you're here, say here. If you're not here, send me an email when you're watching this, okay? Here we go. Seems like 10 is pretty good. I think I found all of you. Okay. All right. First glance, do we understand what's going on? So there are 9 judges, right? Everyone has to shake everyone's hand, and how many handshakes occur in the room with 9 people? You want to show multiple representation to provide evidence for your answer. Include a table, diagram, different amounts of people, starting with 2, since one person can't shake their own hand, even coming up with expression or equation to get an answer. Okay, well, here we go. Diagram, right? So I'm not gonna draw like people. Okay, I'm gonna draw a dot because you're a dot. Okay, obviously when n equals 1, when you have one person, you have 0 handshakes. Yay! All right, left hand, right hand don't count. Okay, we're not into that kind of stuff. Okay, when n is 2, you have 2 dots, two people, right? How many handshake do you get? 1. Got it? That's it. All right. When you have 3 people, how many handshakes? Well, let's see. 1, 2, 3, right? You can shake with him, you can shake with him, you can shake with him. That's it, right? You with him, because you can only shake with 2 people if you are one of the 3, right? So you get that. So 3 total. So where's it good? When n is 4, it's much more interesting, right? So you have 1, 2, 3, 4 people. Okay. I can shake with you, and you. I can shake with all 3 as well, but I already shook with you, so these 2 I haven't shaken. These 2 I can only connect there because each person will shake 3 people, right? So I have 1, 2, 3, 4, 5, 6. 6. So where's it good? N equals 5. Then you keep drawing, right? So 1, 2, 3, 4, 5. Each dot basically has to connect with all 4 others. Only once. Exactly once. Okay? Alright. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 10. Okay? And then you keep going, right? Keep going. That's a diagram. You go all the way to 9. Now, what else can we do? So, let's try to add like a unique handshake. Okay, so let's give, so there are 9 people. Okay, so person 1. So we'll do it like this. Okay, person 1, person 2, person 3. I don't know what this is. 4, 5, 6, 7, 8, 9. Okay, we're gonna add new handshakes. Okay. All right. So if I am the first person, okay, how many handshakes, new handshake can I add? So nobody's shaking anybody right now. How many handshake can I get? If I'm the first person who initiates handshake, how many new handshakes can I get in the group? Well, there are 8 other people, right? So it has to be 8. Okay. Now I'm person number 2. You change perspective. Now you're person number 2. The first person just shook everybody. Okay, everybody got shook. So now you can't shake the first person anymore because you already shook with him. But you could shake with every other person, right? So it'll be 1, 2, 3, 4, 5, 6, 7. Then you change perspective. Okay, now the second person has gone through his handshake. Now person 3. Well, you already shook person 2 and 1 because they already shook with you. Now you can only shake these guys, so you get 6, right? 1, 2, 3, 4, 5, 6. Then number 4. 5, 5, 4, 6. 3. Person number 7 gets 8 and 9 only. 8 gets only 9, so 1. And then when you're the last person, you're like, oh, it's my turn to initiate. Oh, wait. Everyone already initiated, so I got nothing. Okay? So when you add these up, these will be your number of handshakes total, which would be, if you add them up, you should get, what? 15, 21, 36? But wait, doesn't this feel like a thing that we've done? Remember when we talked about this triangular number thing? Start with 1, 8 people. So wouldn't this be, or you can say 9 people, but you start with 0. So if you do that, isn't this 0 plus 8 times 9 people divided by 2, which will also be 36. Okay, same thing. Or if you don't want to count last person, it will be 1 plus 8 divided by 2 times 8. It will be same thing. Okay. Huh, interesting. So let me ask you this. Can you give me an equation for any number of people? If I have n people, all right, let's just say in this class we have 30 students. Okay, 30 students. How many handshakes? Okay, so this is a classic permutation kind of problem, or choices type of problem, which we basically think about as, I have 30 students, right? Every student can shake with the number of student minus 1, because you can't shake with yourself, right? So if you have 30 students, every single one of them can shake with 29 people, right? So you multiply that by 30, right? 30, because you have 30 students. Every student can shake with 29 people. But if I shook with you, you shook with me. So there's a repeat, right? There's a repeat. So you have to divide by 2, right? Because you only want to know how many handshakes. You don't want to know, like, you don't want to double count, right? So if you multiply this out, 15 times 29 divided by 2, you will get 435 over 2. Wait, that doesn't sound right. Yeah, 435. 435 handshakes. In other words, any n people, you will have n times what? N minus 1 over 2 handshakes. That's it. Okay. All right. Comfort level 1 to 10. Eight, 10, 10. How come we did the example with 100? It was n plus 1, now it's n minus 1. Good point. So, in the example you have, right? In the example you had, you start with 1, right? You start with 1 and end with 100. Okay? So, yeah, it's first plus last. So, if you think about, yeah. All right, good point. So, when you are doing triangular numbers, you start with 1, right? And you end with 8. Right? But right now, we start with 0, end with 8. So, you really have 9 people, but you start with 0. So when you add 8 plus 0, right? 8 plus 0 instead of basically you have to take out 1 because the last person didn't get a new handshake. Okay, so triangular number is kind of like you start with 1 and you add 8, right? So it's 8 plus 1. But this you start with 8 and with 0, so 8 plus 0 like this times 9 divided by 2. So it's the same thing as first plus last, right? First plus last times how many people you have divided by 2, right? So it's the same thing, except you start with 0 instead of you start with 1. That's why it was n minus 1 here instead of n. This is to account for the last term being just 1 short. Okay, because you start with 0 instead of 1. If you start with 1, then it would be n plus 1 instead of, because if you start with 1, then this will be n, this term will be n, this term will be n plus 1. So you get n times n plus 1 over 2. So it's an index problem. Okay, it's a matter of where you start. Does that answer your question? No. So yeah, the universal rule is first plus last, and it has to follow a specific pattern, which we'll talk about next week, which is when it goes down in constant terms. So like if it's arithmetic, okay. So right now it's going up by 1 or down by 1, right? If it's going up by 2, down by 2, it's still the same thing, right? We're still looking at the trapezoid. I like to do it in geometry terms, right? So right now you have 0 and 8, right? And then you have 9 here, right? The thing before, you had 1 being your first term, 100 here, and you have 100 term here, right? So it's the same model. It's a trapezoidal rule, but you are starting with a different base, basically. Okay. Does that answer your question? Okay. So homework, right? So this week we don't have any formative assessment, but your homework is already on Google Classroom. This is due on the 3rd of May. This is Sunday night again. If you haven't turned in your previous assignments, I think I graded one before this week. Not the one that just due, but everything I've looked at. I already gave you credit on Google Classroom, but Schooloo has been down, so I can't enter grades. But if you turn it in, then this is on Google Classroom, okay? So the assignment is called Square Numbers. And it's a worksheet, okay? It's due Sunday night. And as soon as Schooloo comes around, I will. Number 8. Which one's number 8? Let me see. Talking about number 8 on recursive sequence. There's no number 8 though. I only see population. Oh, day 4, that one. So like if Pn presents the number of intersection points you can get, that one. Let me grab the paper. Talking about this one, right? Huh? Okay. So let's talk about this. Okay. Say if Pn represents the number of what? Not this one. Other worksheet. One sec. Which worksheet? Let me see. Give me 1 sec. Let me try to find which one you're talking about. Day 3. One second, I'm trying to find the one you're talking about. Day 3. Number 8. Are we talking about this one? So is it a sequence problem or is it a word problem? The word problem? Let me see. Did it just happen? This is sequences. Oh, the other recursive problem? Oh, I see. Okay, day 3 sequences series. So it says you start with 6 million people, that one. So 6 million people, right? Population 6 million, and grows 1.5%. Grows 1.5% each year. That one. And additional, and then you have plus 50,000 in addition, right? So you want to give a recursion equation for Pn, okay? Is that the right problem? I'm looking at the right one. Oh, okay. So there's 2 parts of this problem. Number 1 is that you have a issue with a growing population linearly and an exponential, okay? So to do let me see. So they first want a recursive because recursive is easier to do here. So what we will do is going to be Pn plus 1. Usually I like to start with n plus 1, but you know, you can do n and n minus 1. It doesn't matter. Pn current is going to be multiplied by 1.5%, right? So but that's 1.015 because 101.5%. Plus an extra 50,000 every year, like this. Okay, so that's part A. Does that make sense? And then your P1 is equal to 6 million. Okay, so this is your recursive. Okay, and then part B, really you just start doing it. Okay, part B, they're asking you, part B, they say, if now is 8,500,000, what about in 5 years? Okay, so then you'll use this formula 5 times, basically. Okay, do it 5 times. So does that make sense? So you multiply this by that plus 50,000 to get the next one. So now is this. So then year 1, you'll get 55, right, like this, times 1.015 plus 50,000, like this. That's what you get for year 1. Okay, multiply this out, add this. Okay, so that, I think that equals to 8677500. I think there's one more 0 here. Like that. Wait. I think there's too many. There's only one. So here. Okay, no 0 here. And then you use this number and you plug into the next one. So year 2 will be 8677500. Like this. Times 1.015 plus 50,000. And then you get the next one. Next one is like 885766.2.5. And you use this to do the next one. And you put it here, 885766.2.5 times 1.15 plus 50,000. And then you keep going until year 5. Okay? This is the power of recursive. Is even if you can't figure out a general formula for explicit, you can keep going to get the next one. Okay? Anything else before I let you go? Well, if there's nothing else, you're free to go. If there's something that you can't think of, but you think of something else during the day, you can shoot me an email, shoot me on Remind. I'll do the problem, or I can just answer you, or I might just stream it on office hour, and then I'll tell you to look at it. You guys know your homework, right? Goodbye. No problem. Bye, Remy. No problem. See ya.